Hello everyone. As part of learning Scoop, we were looking at the import statement. In the previous session I have shown how do we create a widget table, inserted 3 rows and try to import data using Scoop import command, right. So when you are trying to import to Scoop the data using Scoop import, it will try to generate a text file which is a comma separated data. So whenever you are trying to generate a comma separated data, the text file delimiters are fixed. For every field it will try to just insert a comma and it is looking like a CSV file, right, but it is a text file. But these delimiters, if you do not want to use a comma, you want to specify a space or you want to specify a pipe sign, whatever you want, you can specify in the import statement itself. And field enclosing escape characters. Suppose you do not want to use any of the separator, you want to put slash star before beginning any field value and while ending you want to put star slash. You can specify field enclosures also. And all these things can be given just to have better processing requirements. If at all you are having, you can try to use various separators. Now just to see this one, Scoop import, again I have given the syntax. And as I told, it is trying to generate a text file, right, and Scoop is capable of importing data into different file formats. Text files offer, they give you human readable representation of the data, and majority of the time why do we go for text files by default is its platform independence nature and easy to read by the users. Sometimes they cannot hold binary fields. Say for example in my table one of the data field is var binary, or I have something called as a raw data type. In such case text file cannot hold that binary information. In such cases I might need to switch to a format which will hold the binary file, right, because text file what it will try to do is if at all I have any binary information in the table, while importing in the text file it will replace it with a null value, and processing the null values the user might think there is no value, but in reality there was a binary value. Text file could not represent that, it was showing it as null. So which might misinterpret the results, right, or which might not give me expected results. So in such cases what are we trying to do? Scoop supports sequence files, Avro files, Parquet files, etc. All these things can hold the binary information. These binary formats provide more precise representations, and MapReduce can definitely process them, all these file formats. MapReduce not only works with text files, it can process any of these files. So whether you are trying to work with text files or binary files, it depends on what type of information do you have in the database while working with imports. Next one, generated code. What is the context of this one? I have shown you in the example working with import. Whenever we give import command, Scoop internally runs a MapReduce program in order to execute that particular command. If you want to see what is the MapReduce Java code it has generated, you have the option, we call that as the generated code. You have the option to see the code using the command Scoop codegen. Codegen stands for code generator. Connect, again connect to MySQL localhost, under which what was the example database we were working with, Hadoop guide. What is the table to be connected to? Widgets. And then what is the class name it has to generate? Widget. You can specify. You do not specify that, it will generate it with the same table name as the class name. So this codegen command will try to show you what is the MapReduce code it has generated in order to work with import command. Then Scoop is importing data from a database by running a MapReduce job, and which is trying to extract rows from the table and puts them into HDFS file. So how exactly it is doing that? I have a database. When the database partitions are there, multiple mappers will be working and they are trying to put the data into HDFS folder. So whenever you are trying to work with this Scoop client, it is first trying to get the metadata of the table. What it will try to do is, just see this one. First, before the import can start, Scoop uses JDBC to examine the table it has to import. It retrieves a list of all the columns and their SQL data types. So first it will observe the metadata of the table it has to import. What are the field names, what is their data type, what are the constraints on them, all that metadata is observed. Once it is observing that, it will try to identify, can my Java file, or it will try to do a mapping. What type of mapping it will try to do? Suppose SQL varchar is there. What it should be mapped to? Java's data type. Why I am talking about Java? Because MapReduce code is written in Java and Scoop is automatically generating MapReduce code. So it will try to see the table's column definition, its data type, and matches them to, or gives a mapping to, Java's primitive data types, right? So just go through this. After observing the SQL data types, they can be mapped to Java data types. Say for example, varchar is mapped to string, integer in Oracle is mapped to integer, and so on, which will hold the field values when you are working with MapReduce application. And Scoop's code generator will use the information and it will try to define the respective classes in order to hold the information into the text files. So say for example, if you are working with the same widget class, widget table, what are the attributes we have? ID is there, widget name is there, price is there, design date is there, version is there, and design comments are there. Automatically it will see the field names and all the inspector functions have been designed. What are the inspector functions? The get functions. All these inspector functions have been defined automatically corresponding to the specific data type. If you see, ID is of integer data type, widget name was varchar, so it is mapped to the string data type, and get price, it was a float value, it is defined to math.bigdecimal, and so on. So it will first observe the data types of the table and tries to map them onto Java's built-in data types, and the respective functions are automatically generated when we are working with the code generator. Similarly, it automatically takes care of serialization. What are the methods it uses for serialization? From the DB writable object, it will try to take read fields. What is the data parameter we are trying to send? Result set. Because we are working with JDBC, it almost uses the same objects like prepared statement, result set, all these objects. So it will try to work with the read fields method, also the write method. I will talk about write method, what exactly it is trying to do. So the result set interface provides a cursor. Why are we talking about cursor? Because what if my table is trying to give me multiple rows? So I have to hold them in a cursor. This is PLSQL cursor. So it will try to provide a cursor which retrieves records from the table and it will try to hold them. This read fields method will populate the fields of the widget object and the columns from one row of the result set data. So it will try to put them in the cursor. That read fields will try to take one row from the cursor, writes them into the file. Second row from the cursor, writes them into the file. Likewise, the write method will be used in order to publish the processed results onto the client's database site again. Say for example, whatever processing I have done using MapReduce, I want to send the results back into Oracle on the customer side or client side. In such case, write method will be used for exporting. Right? Now, whenever we are working with databases, what if my database is having so many rows? Say for example, 1 lakh rows. Is it possible to have 1 lakh rows? Definitely yes, we are working with huge amounts of data. So say for example, my table is consisting of 1 lakh rows. To enjoy the benefits of parallel processing, what we do is we try to slice the rows of the table based on the key value. In our example, what is the key value? The widget ID is the key value. So say for example, I have 1 lakh rows, first 20,000 maybe into one mapper, second 20,000 records into another mapper, likewise. So if I have 1 lakh records, maybe I need 5 mappers, right? So if you come back to the import statement, I was specifying -m -1, it is not -1, -1, -m -1. If I identify my table is having very few number of rows, and if I feel one map function can finish off the job, I am specifying it, please finish it with one map function. If you do not specify that -m -1, by default it defines 4 mappers, right? So you have to decide how many mappers you want to work in parallel in order to process the data from the table. So in our example, if my table is consisting of 1 lakh rows, I can decide if I want to go for 5 map functions which can run parallelly, we specify -m -5 in the import statement. This kind of slicing a table horizontally to enjoy the benefits of parallel processing, we call it as splitting. Splitting column. Which column are we using for splitting? The primary key. Most of the time it is the primary key which decides how many rows are going into a split. So how do we define? For example, I have taken select minimum ID and max of ID from the widget table, which will tell me what is the minimum value, what is the maximum value. Subtract from the maximum value the minimum value, I get the range. Based on that I can divide. So say for example, I have done the division like this: 0 to 20,000 in one partition, 20,000 to 39,999 into another partition, and so on. So if I have 1 lakh rows, I do get like this. And why should I always take primary key? Is there a rule? Definitely not, but generally we expect primary key is distributed uniformly, we select the primary key. If not, sometimes suppose there are no widgets whose ID is between 50,000 to 75,000, that entire partition will have less number of rows compared to other partitions. Simple example, say for example I have a set of students which I have combined across all the sections, and I told all the roll numbers between 1 to 20 of all the sections should sit in one room. Suppose by chance that day 11 to 15 are absent in every section, I will have definitely less number of students in this partition compared to other partition wherein all the students were present. So I say the splitting did not happen uniformly, right? In one section I might have less number of students, in other section I might have more number of students. So if we are not taking care of the range of values of the attribute with which we are splitting the data, the distribution could be uneven. And how do we control the import statements? Whenever we are working with import, say for example, I do not want to take all the rows from the table. I want to take all the employees, say for example, I have an employee table. I want to take all the employees whose salary is less than or equal to 10,000. How do we control this query? We specify salary value less than or equal to 10,000. The where clause of the SQL can help us in order to selectively take rows from the table and put them into my HDFS file. So it is not always necessary to take all the rows from a table. Conditional selection is also possible, which we call as controlling the import. While importing the data itself, you can specify the condition which will try to take the data which is satisfying that particular condition, right? Thank you.